So now that we have our equation of a parabola, actually kind of four equations for a parabola, let's take them out for a ride and see what we can do with them. We're going to follow a very similar pattern here to things you've probably seen before, because you do know some analytic geometry equations already, right? You know the equation of a line, which is an analytic geometry equation, and you know the equation of a circle, which is also an analytic geometry equation. We're going to follow a very similar process here. First, we're going to look at some equations and get information from them. Then I'm going to give you information, and we'll use that information to derive the corresponding equation. And then finally, we'll see how we can take that vertex and shift it off of the origin. All right, so let's say we have this equation here. Now, the first thing you're always going to want to do when you're working with these things is figure out which way it opens. Does it go up, right, left, or down? Okay, so which way does this thing go? Well, you remember, right? Hopefully you remember from your algebra classes. This has a y and an x squared. That's kind of your classic quadratic equation. So this is going to be either an up or a down. And because of this minus sign here, right, that makes it a down facing parabola. So I'm going to sketch that in here, right? Remember, we're still making this assumption that the vertex is at the origin. So I know I've got my vertex here, and I know it opens down. And now I know where all the other parts are. The focus has to be inside the parabola, and the directrix is always outside the parabola. So now all that's left is to find that value of a. Oh, you remember, 4 is kind of the magic number here. I need this to look like x squared equals 4, excuse me, we're going to leave the minus out there, minus 4 times something y, and that something is going to be a. All right, well, minus 4 times 5 is minus 20. So since a is 5, I now know where all of my parts are. The focal point is 1, 2, 3, 4, 5. It's 5 units inside the parabola. And the directrix is 1, 2, 3, 4, 5 units outside. Well, the coordinates of that point are 0, negative 5, and the coordinates of that line, excuse me, the equation of that line is y equals 5. And that's it, right? Now, those are the three things that we need to describe this particular parabola. All right, so going the other way now, right? Find the equation of the parabola whose vertex is at 0, so we're starting with this same setup, right? The vertex is here, and whose focus is at negative 5, 0. So I'm going to go negative 5, 1, 2, 3, 4, 5, comma, 0. There's the vertex. There's the focal point. Okay, so again, right, I'm always going to start off, I'm a very visual person, always going to start off with a sketch. I know that the focal point has to be inside the parabola, right? Well, if it's going to be inside the parabola, then it needs to be this left facing one. Okay, so now I know the general shape. What is the general equation of a left facing parabola? Well, the left and right ones, those have a y squared and an x, and the left one has the negative 4a. All right, so all I got to do is figure out a, and I'm home free. Remember, a is the distance from the focal point to the vertex. That's going to be 5, and it's positive 5. It's a distance, right? Always think of this a as a distance, so it's always going to be a positive number. So if I put 5 in here, I get y squared equals negative 4 times 5, which is negative 20x. And that's it. There's my equation, right? There's the equation of this parabola. All right, so let me give you one, right? Go ahead and pause if you like, right? Take a minute, see if you can't work this out, then start it up again. We'll go over it together. All right, so you see the vertex is still at the origin, right? That hasn't changed. And the directrix is y equals negative 2. So the equation, the graph of y equals negative 2 is down here. Okay. Well, the focus is always on excuse me. Is always on the opposite side of the vertex from the directrix. So if the directrix is down here, the focal point has to be up here. And this distance is going to be the same for both of them. And that distance is my A value. Okay, so now let me put this down here where it's a little out of the way. I know that my parabola is going to look like this. That opens up, right? The general equation opens up. That's x squared equals 4ay. And because a is 2, the specific equation is x squared equals 8y. And that's it. There's my equation, right? That's all I was looking for. Okay. So suppose I want the vertex to be somewhere else. Okay, well, here's what I'm going to do. Right? If I want my vertex to be over here, let's call this point h, comma, k. Okay, and let's pick one to talk about. Let's say we're doing our kind of our standard upward opening parabola. I know the equation of this thing is x squared equals 4ay. Well, all I want to do is I want to take this thing and I want to relocate it. Right? I want to move it over h units to the right and k units up. Well, we know how to make that change, right? To make a translation of h units to the right, I replace the x with x minus h. And to make a translation of k units up, I'll replace the y with y minus k. And that's all there is to it, right? That's my equation of a parabola whose vertex is somewhere other than the origin. And what I've done here, textbooks like to do this. They like to write all of these things out. But if you go back to the previous lecture, or if you look back at your notes where if you wrote out all 4 where the vertex was at the origin, these are the exact same equations. The exact same equations. I've just replaced the y's with y minus k and the x's with x minus h. All right, so how can we use this? Well, let's look at some more examples. Look at this thing. I want to find the equation of a parabola whose vertex is someplace other than the origin and whose focus is at 3, 4. Okay, well, let's sketch this. I'm going to go over 1, 2, 3, down 2. There's my vertex, right? And I know the focus is at over 3, up 4. So I'm going to go up 1, 2, 3, 4. There's my focal point. Okay, so good. Now I know my parabola looks like this, right? Because the focus has to be on the inside. And I know that this distance here is A. So A equals 6. So here's what I'm going to do. I'm going to find the equation just like we did before, right? Just like we did before when the vertex was at the origin. Then all I'm going to do is I'm going to translate it, right? So this is an upward opening parabola. So I know that my equation is x squared equals 4ay. and y was 6. So it's x squared equals 4 times 6, that's 24y. Okay, so this parabola, the parabola that goes with this equation, looks identical to the one I'm trying to find, only it's over here instead of down there. Okay, well, to get it there, I'm just going to do a translation. I need to go 3 units to the right. So I'm going to replace the x with x minus 3. Oops, not plus, equals 24. And I need it to go 3, where's my vertex? 2 units down. So I'm going to replace the y with y plus 2. And that's it. There's my equation. Now, I am perfectly happy with the answer being left that way. Okay? Other professors may feel differently. If you're using that MyMathLab program, for example, I know MyMathLab feels differently. They may want you to multiply this out, combine like terms, just one time so that you can see what that looks like. I'm going to do it. All right, but for my purposes, if you left it like this, I would have been perfectly fine with this as an answer. So let's see. If we multiply out this left side, this is x minus 3 times x minus 3, right? So that's x squared minus 6x plus 9 equals 24y plus 48. And then let's combine some stuff. Let's subtract 48 from both sides. X squared minus 6x minus 39 equals 24y. And then ultimately we're solving this for y. So if you divide both sides by 24, y is x squared minus 6x minus 39 over, over 24. Not sure why the view changed there, but that's okay. So again, this is not, to me, anyway inherently better than this. I would take this for an answer. Other people may expect you to go and do this instead. So let's look at another one. Here, we know the vertex and we know the directrix. So again, let's start with the same process, right? I'm going to graph this. The vertex is at over -2 up 1. That's up here. And the directrix is at x equals 2. That's right here. Okay, so the parabola will go through the vertex. So it's going to look like this. It's going to be opening to the left. And I know that my opening to the left equation, it's got to have an x and a y squared, right? So it's going to be y squared equals, then because it's going to the left, I'm going to have -4a over here. All right, now what is a? A is the distance from the vertex to the directrix. That's 4, which remember is the same as the distance from the vertex to the focus, right? So whichever one you've got, that's fine. That's the one we can use. So my equation is looking like y squared equals -4 times 4. That's -16x. Now, that's not really my parabola, right? That is this parabola. So I just need to move it over, right? I need to shift it 2 units to the right. So this will be -16x plus 2. And I need to shift it 1 unit up. So this part becomes y minus 1. And that's it. Stop. Don't multiply it out for my sake. I'm perfectly fine with that as the final answer. Okay, so how about this one? Okay, first, ignore this A here at the end. That's a typo. So, okay, now, how about this thing? I want to analyze this. So just like before, I want to know where is the vertex? I want to know where is the directrix and where is the focal point. Okay. We've got a little bit of a problem, right? I need it to look like this. I need it to look like y minus k squared equals 4a x minus h. Maybe there'll be a minus in front of the 4, maybe not. It's going to depend on which direction it opens. Okay. How am I going to do that? Well, look, we have a method. We can do this, right? It's called completing the square. If I complete the square over on the left-hand side, that will let me make the left-hand side look like this. Then I can worry about cleaning up the right-hand side. All right, so what I'm going to do first, I'm going to move that minus 4 over, get it out of the way. All right, so this will be y squared minus 4y, and leave a blank there, equals 8x plus 4. Okay, so what am I going to add? You remember how we complete the square? I'm going to take that number that's in front of the y. I'm going to divide it by 2 and square the result. If I do that, I get plus 4. So that's what I'm going to add to both sides. Okay, the left-hand side is now a perfect square. This is y minus 2 squared equals 8x plus 8. Now, okay, the left-hand side is squared away. I'm not going to mess with it anymore. The right-hand side, I need to make it look like this. I need to get rid of any number that might be sitting there in front of the x, because it has to be x minus h, not 2x or 5x or 8x minus h. So I'm going to, whatever number's in front of the h, whatever number's in front of the x, factor it out. I don't care what it does to the other number. Right? So I can factor an 8 out here, and this one turns out nice. It's 8 times x plus 1. If that 1 had turned out to be a fraction, then it's a fraction. Right? There's nothing wrong with that. It would be a fractional vertical shift. All right, so now I'm where I need to be. Y minus 2 squared equals this. And remember, we need this constant out here to be 4 times something. And 4 conveniently goes into 8. This is y minus 2 squared equals 4 times 2 times x plus 1. Okay. Now, you can try to pull the bits of the focus and all that out of here if you like. The vertex we can actually get easily, right? The vertex, this is the h, this is the k. So the vertex is at -1, 2. You notice those signs got reversed, right? Because it's x minus h and y minus k. If you think back to when you learned about the equation of a circle, right? It's the exact same thing that's happening here with those signs. Okay, now, so where is that? Well, let me graph that. Over -1 up 2. There's the vertex. Okay, what kind of parabola is this? Well, look, this is positive, and the y is being squared. So this is an opens to the right parabola. Okay, so let me sketch that. I'm going to start at my vertex, and I'm going to open to the right. Okay, this tells me where all the other pieces are. The focus is on the inside. The directrix is on the outside. Okay, and I know what A is, right? A is 2. So this distance here is 2, which means this, I got this exactly right. That was just dumb luck, right? This point is over 1 up 2, and that's the focus. And the directrix is 2 in the other direction, well, this was x equals -1, so this is going to be 2 to the left of that. That's x equals -3. And there's my points, right? My points, there's my information. Those are the properties that I was trying to find. Okay, so why don't you pause the presentation here, right, and see if you can work this one out, then go ahead and start it back up, and we'll do it together. All right, so we've got to do the same thing, right? I'm seeing I've got the x is being squared, so I know I need x minus h squared equals 4ay minus k. Okay, so let's see. I don't have a constant on the left-hand side, so we don't have to worry about that. I can go right to adding whatever I need to complete the square. So I've got x squared minus 4x. Remember how we find our number here. I'm going to take that -4 divided by 2 and square it. So I'm going to add 4 to both sides. And this equals y plus 4 still. And I'm going to add 4 over there. All right, so the left side factors. This is x minus 2 squared equals y plus 8. All right, so the left-hand side is squared away. Awesome, that part's done. I got to get some number out in front, right? This is going to be x minus 2 squared, and I need this to be 4 times something times y plus 8. Okay, there was nothing to factor out of the y, right? There was no number in front of the y, so I'm fine with that y plus 8 just like it is. I just have to force that 4 to be out in front, right? And how am I going to do that? Well, look, put 1/4 here, right? 4 times 1/4 is 4, and nothing changed, right? That's still 4 times 1/4 is 1, and that right-hand side is still y plus 8. Okay, so this is what I need. My vertex is going to be a little messy because we're going to have a fraction for a, but that's okay. My vertex is at 2, -8. So let me go over 2, down -8. There's my vertex. Tell me this thing doesn't open down or I'm out of room. No, it doesn't, right? We have a y and an x squared, so we know it's an up and down. And this part here is positive, so it's an up. So it's going to look, pardon my very sketchy drawing skills. It's going to go in that general direction, right? So now what? Where are our focus and directrix? Well, it helps. Don't be shy about labeling stuff in this drawing. This is the point 2, -8. I need to go down 1/4 from there. So the x coordinate is going to stay 2, and it's going to be -8 minus 1/4. So I know I usually say, yeah, fractions, there's nothing wrong with, well, let's do fractions, right? We need a common denominator that's going to be 4, so this is going to be 2, -33/4, right? So that's going to be my directrix, right? It's going to be right here. It's going to be y equals -33/4. And then I have to do the same thing. I have to go up, right? I have to go up a quarter. So at that point, the focal point is going to be 2, -8 plus 1/4, which will be 2, -31/4. 2, -31/4. And there are my parts, right? I've broken down this parabola, found all of these relevant properties and attributes. Okay, so that's parabolas, right? That's parabolas. There are two more of these conic sections for us to discuss. So from here, we're going to talk about ellipses, and we're going to follow a very similar pattern. We're going to start with a geometric definition. We're going to use that to get an algebraic or analytic geometry formula definition. Then we're going to follow the same sequence of steps. I'm going to give you an equation and we'll get information about it. Then I'm going to give you information, we'll get the equation. All of this making that same assumption that in the case of an ellipse that the center is at the origin. And then we'll use the same transformation trick, if you will, to move the center somewhere else.